Okay, last time we were getting a little bit confused when we were talking about impulse, and we were using an example of an egg that was being dropped from some height. So let's go back to it. We're at the position now where the egg is just about ready to hit the floor, and it's maybe a fraction, just a small, tiny fraction of a way in the air where its final velocity just before it hits the floor is 5 meters per second, and in a twinkling of an eye it hits the floor and it stops. So it goes from 5 meters per second just before it hits to now it hits and it's stopped. So it's at 0 meters per second. So in order to change this momentum, in order to stop it, remember, if something's going at a certain speed, the only way to change that speed is if some force acts on it. You got to either push it to go faster, or you could push it in front of its motion to slow it down. In any case, you have to apply some kind of force in order to get it to slow down. And the force in this case that slows it down is the force of the floor, which acts upward on the egg. So let's show that. Right over here, as soon as it makes contact, at that very instant, there's a great force that's applied to the egg from the floor. So it experiences a force, and this force is going to act, say, acts on egg for only a very small time, delta t equal to 0.001 seconds. So 1 microsecond. In 1 microsecond, the velocity is going to go from 5 meters per second to 0. Very, 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 very short time to change the velocity from 5 meters per second to 0. So we want to say, well, what was this force then? So our impulse equation says force times change in time is equal to the change in the momentum. This is impulse here, force times time. So let's look at this impulse. Force times time, which is 0.001 seconds, is equal to the change in momentum. Well, here the momentum, here's the final momentum is 0. So the final momentum is mass times v final minus mass times v initial. The mass is going to be 1 kilogram, but over here it's going to be 1 kilogram times a final velocity of 0 minus the mass, which is 1 kilogram, times the initial, which was the right here. This is now initial position. This is final position when it hits the ground. The initial, if we consider up as positive, then the velocity here is negative, so it's negative 5 meters per second. So you see, this is 0, minus times minus is plus, and we get 5 kilogram per meter per second. That's the change in momentum that's brought about by this force. So force times 0.001 is how long it takes. That's how long the force is acting. All right, that force acts very, very briefly to change the speed of the egg from 5 meters per second to standstill. So if you calculate F, you divide both sides by 0.001, you find F has to be 5,000 newtons. Large enough force to crack the egg. And that's what happens. Eggs crack when they hit the floor because they change their momentum very, very, very quickly, which means that the force has to be very large on the egg. Now let's see what happens, or what would happen, if we put a pillow, a nice pillow on the floor, and here comes the egg, and just before it hits the pillow, it's going to be traveling at 5 meters per second. And now, because we have a pillow, what happens is the pillow will tend to cushion the egg, and so the pillow exerts a force. Let's do it in yellow since that's what you're used to. The pillow will immediately start exerting a force upward on the egg to change the velocity from 5 to 0. Okay, here the velocity is 0 meters per second, right here at this point. So there was some delta t, some time it took from the egg to go from this position to all the way the dented in position, but as it's going, it's denting, and then it stops and the egg is stopped. So it takes longer, in this case, to stop the egg. Egg just hits the pillow at 5 meters per second, and now it's going to take a little bit longer. Let's say it's going to take only 0.1 seconds to slow the egg down to 0. So here it's 5 meters per second. When the egg finally stops, it finally stops 0.1 seconds later, and that is because there's a force F of the pillow acting on it. So let's calculate this force F. F times delta t in this case is 0.1. Equals the change in momentum, which is mv final minus mv initial. In this case, its mass is 1 times the final velocity is 0 minus the initial mass is still 1. The initial velocity is going to be negative 5 meters per second because it's traveling down. So this is still 5 kilogram, because this is kg, times meters per second is equal to F times 0.1. And you calculate this and you see F is equal to 50 newtons. So look at the difference in the force. Here the force was 5,000 newtons. Here, because you put a pillow, it took longer to change the momentum of the egg from 5 meters per second to 0 meters per second. So this length of time that took a little bit longer, you reduce the time, which made the force, actually you increase the time, you increase the time by a factor of 100, which caused the force to drop. So if we look at this equation F times delta t is equal to the change in momentum. Notice the change in momentum is constant. It has to be some constant number. In this case, our change in momentum is going to be 5. And it doesn't matter how long it takes to change that momentum. The momentum change comes about because we're saying to go from some velocity to 0, whatever this was. In this case, this was 5 kg meters per second. That's what our momentum was. So what you had was this situation, force times time is equal to 5. If you increase the time, you have to decrease the force, because force times time equals 5, right? So if the time goes up, the force can come down. If the if the time goes down, it happens shorter time, the force then has to go up, because one quantity times the other quantity has to give you 5. See it? So if you have a force of 5, let's say 5 times 1 is equal to 5, right? This stays constant. That's your change in momentum that you're interested in. If you increase this time, let's make the time 5, then your force drops down to 1, because it still has to give you the same change in momentum. So a game is played between force and time. You increase the time, you'll lower the force. I hope that helped, and maybe we'll just talk a little bit about it next video, and then we'll move on.